Hello everyone. I hope you all are doing well in this pandemic. This is Sumti Mehta and I am pursuing my BTech from Rajiv Gandhi Government Engineering College, Kangra. I am the student of Electronics and Communication. Today I am here to give the presentation on I2C protocol. I2C stands for Inter-Integrated Circuit. Why we require I2C protocol? Many of today's applications require high bus speed and lower supply voltages. That's why we require the communication protocols. The I2C bus was designed by Philips in the early 80s to allow easy communication between components which resides on the same circuit board. Philips Semiconductor migrated to NXP in 2006. The I2C stands for Inter-Integrated Circuit and it is pronounced as I2C and it alternatively known as I2C or IIC. It is synchronous, multi-master, multi-slave, packet switch, single-ended serial communication bus. There are some generations of I2C. The I2C firstly generated in 1982. In 1998, a higher bus speed and lower supply voltage is released. 2007 In 2007, introduced by NXP Fast Mode Plus. In 2012, a user manual is released. There is architecture of I2C. The I2C connects multiple slaves to the single master and we can have multiple masters controlling single or multiple slave. This is really useful when we want to have more than one microcontroller logging data to the single memory card or displaying text to a single LCD. I2C only uses two wires to transmit the data between the devices. SDA and SCL. SDA is serial data line. The line for the master and slave to send and receive the data, and SCL is serial clock, the line that carries clock signal. I2C is a serial communication protocol, so the data is transferred bit by bit along a single wire. It is a half duplex circuit. I2C is asynchronous, so the output of bit is synchronized to the sampling of bit by clock signal shared between the master and the slave. The clock signal is always controlled by the master. There is only two wires is used. The maximum speed of the standard mode is 100 kilobytes per second. The maximum speed of fast mode is 400 kilobytes per second and higher speed mode is 3.4 Mbps and ultra fast mode is 5 Mbps. Next is I2C nodes. I2C nodes consist of AVR microcontroller, analog to digital converter, and electrical erasable programmable read-only memory and some electrical components like register. It can function like master or slave. The clock is generated by the master. The master device addresses the slave. Both the master as well as the slave can transmit as well as receive data. Four operating modes are master transmitter, master receiver, slave transmitter, and slave receiver. A node can have more than one operating mode. However, at the time it has only one operating node. Start condition. The SDA line switches from a high voltage level to a low voltage level before the SCL line switches from higher to low. We can see from the figure when SDA line is high and SDA is switching from higher to low and SCL is high, then it is called the start condition. Stop condition. The SDA line switches from a low voltage level to a high voltage level after the SCL line switches from low to high. From the figure, we can see that when STL line is switches from lower to high, then and SCL is remaining high, then it is called the stop condition. Packet format in I2C. With I2C, data is transferred in messages. Messages are broken up into frames of data. Each message has an address frame that contains the binary addresses of the data from data frame that contain data being transmitted. The message also includes start and stop conditions, read write bits and acknowledgement bits. From the figure, we can see that a most significant bit, least significant bit is the data read and write signal and acknowledgement signal. Data format. A transmission is started by a start followed by an address packet, one or more data packets, and finished by a stop bit. After the master detects the acknowledgement bit from the slave, the first data frame is ready to send. The data frame is always 8-bit long and sent with the most significant bit first. Each data frame is immediately followed by an acknowledgement and not acknowledgement signal bit to verify that the frame has been received successfully. The acknowledgement bit must be received by either the master or the slave, depending upon who is sending the data, before the next data frame can be sent. After all the data frames have been sent, the master can send a stop condition to the slave to halt the transmission. The stop condition is a voltage transmission from low to high on the STL line. After a low to high transition on the SCL line, with the SCL line remaining high. If the receiver has received the last byte of data and there is no more data to be received, or the receiver cannot receive or process more data, it will signal a not acknowledgement. Each packet of 9-bit long, the first 8 bits are put on the SDA line by the transmitter. The 9th bit is an acknowledgement bit or not acknowledgement bit by receiver. Transmit releases the SDA line during the 9th clock. The receiver pulls the SDA line low for acknowledgement or keep it high for not acknowledgement signal. Address format. Each packet may contain either data or address. An address packet consists of 9 bits. 7 address bits. The most significant bit is transmitted first. 1 read write control bit. 1 is for read and 0 is for write, and 1 acknowledgement bit. Write a slave with address 1001101. This is an example of the address. First is start bit, and next data is transmitted according to the most significant bit is transmitted first. One is read and write signal and one is acknowledgement signal. Addresses are 7 bits, so potentially 128 addressable devices connect to the I2C, but only 119 addresses can be used. 11111XX is reserved. 000000 is used for broadcast. All slaves should acknowledged. Clock stretching. The clock stretching is kind of flow control. If an addressed slave device is not ready to process more data, it will stretch the clock. The master will not be able to rise the clock line. Arbitration. Each transmitter has to check the level of the bus and compare it with the level it expects. If it doesn't match, the transmitter has lost the arbitration. If master A wants to put 0010000 on the bus and master B wants to put 0001111 on the bus, master A lost the in the third cycle. Then it is called arbitration. From the figure we can clearly see that. Multi-byte memory write. Burst mode writing, as we know, is an effective means of loading consecutive locations. It generates a start condition. It transmits the slave address followed by 0 for write condition. It transmits the address of the first location. It transmits the data for the first location, and from then on simply provides consecutive bytes of data to be placed in consecutive memory locations. It generates a stop condition. First one is start bit, then slave address, write condition, acknowledgement bit, first location address, acknowledgement bit, data byte 1, acknowledgement bit, data byte 1, 2, acknowledgement bit, and data byte 3, acknowledgement bit, and last is the stop bit. Multi-byte memory read. It generates a start bit. It transmits the slave address followed by 0 for address write. It transmits the address of the first location. It generates a start, that is repeated start condition. It transmits the slave address followed by 1 for read. Read the data from the first location and from then on bring contents out from consecutive memory locations. It generates the stop condition. From the given figure, first one is start bit, then slave address, write bit, acknowledgement bit, first location address, then acknowledgement bit, start, that is repeated start, slave address, then read bit, acknowledgement bit, data byte 1, acknowledgement bit, data byte 2, acknowledgement bit, and data byte 3, acknowledgement bit, and last one is the stop bit. This is I2C module. There are some advantages and disadvantages of I2C. The advantages of I2C is that is it only uses 2 wires. It supports multiple master and multiple slaves. The acknowledgement and non-acknowledgement bit gives confirmation that each frame is transferred successfully. Hardware is less complicated and it is well known and widely used protocol. And there are some disadvantages, that is it is the slower data transfer. It has the slower data transfer rate. The size of the data frame is limited to 8 bits. It is more complicated hardware to implement. Thank you. I hope you understand it well.